Right. And I will start Karamu. Okay, so we before last week we last day holiday against our yeah. So we have started our second unit, mechanics. Right. And under the topic of mechanics, we started linear motion. Right. So this is the topic we discussed in our last session. Right. Then, so under this linear motion lesson, what we have discussed, there are 4 kinematic equations which we can describe any of linear motion. Right? So what are those kinematic equations? What is the first one? Which are V equals U plus AE. So what are the meanings of these symbols? V stand for final velocity, U is initial velocity, A stand for acceleration, T is time. Right. And the second one, S equals UT plus half AT squared. Right. Third equation, S equals U plus V divided by 2 times T. Finally, on the time independent equation, V squared equals U squared plus 2AS. Right? So, these are the kinematic equations we used to solve problems in linear motion. Right? So, under that, I think during the last day, actually I did some. I worked out some questions here. How many of them? 2 questions here. As example questions. As an example question. We have big questions. Yeah. Then I asked you to complete the tutorial up to question number 26, 25. 25, right. So now today's, so we need to discuss the difficult questions, right? I'm not going to solve all the questions because the questions in page number 6, most of the questions I think they're very simple ones. You can easily get the answers, right? So from question number 1 to 15, what are the difficult ones? Difficult ones. The questions where you struggled. Question number 1 we did here. No. No. Answer no dekhe. Question number 1 is okay. Fine. Even among I had a question number. Following the high one තියෙන්නේ. Following පහළ question number 10. Answer no. 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 Question number 10 leave. Right. Before that, question number 10 9 okay. Question number 9. Isn't it? It's right. So let's look at the question number 10. To start. Question number 10. A car moving with a uniform acceleration. That's the acceleration. Takes 15 seconds to attain the velocity of 45. So find the initial velocity of the car and the distance it covered during this time. If the acceleration is going to be the other way, making acceleration in the bottom, what I did to touch final velocity, initial velocity minus 40, minus 40. The final velocity 45, 85. 85 to 15 acceleration again 17 over 3 acceleration. What? Acceleration 1. minus 40 answer then answer final velocity the initial velocity it is 40 final velocity 45 time 15 seconds. Right? We get acceleration V equals U plus A. Final velocity 45. Initial velocity minus 40. Acceleration time is 50. Take this minus 40 to the other side. 15A. Acceleration is 85 or 50. Common fact is 5. 17 divided by 3. No. But make a put here. What you can skip that, right? Because make a acceleration negative
minus 40. Answer and dash.
So ultimately only the answer, sir. Yeah, there is a minus. So this is right. This becomes negative. So it is 5. Right. So 50. Sorry, 5 divided by 50. 1 over 3. Acceleration is 1 over 3. Okay. The negative is 1 over 3. Acceleration is 1 over 3. May no. The negative may make a Ghana make a way. Right? This is not the question asked. Right? So you can correct that the acceleration as 1 over 3 meters per second. Then you can solve. Acceleration 1 over 3 the answer again. Right? Right. So this is actually free work, right? So we assume here acceleration is 1 over 3. Now we can get acceleration as 1 over 3. Now point velocity මේක විශ්වාසமாக හිතේ මම මේක කරේ ඔයගොල්ලන්ට දැන් ගානේ acceleration මොකක්ද කියන්නේ මිසින්නේ ඒකේ වැලියු පුරාලා දැන් තමයි ගාන හදන්නේ. Right. So question asks about the initial velocity. So what is the most suitable equation out of these four in order to find the simple u? V equals u plus at. So you can use v equals u plus at to the motion. Final velocity is 45. Initial velocity is u. Acceleration is 1 over 3. Time is 15. There you have 5. So 45 equals u plus 5. U is 40. Independent. Then the second part, find the initial velocity of the car, initial velocity of the car and the distance it covered. So distance it covered is given by s equals ut plus half at square. Initial velocity is 40, time is 15 plus half, acceleration is 1/3, time is 15 and square. By 40 times 15 is 600. Five into 15, 75, 75 divided by 2, 37.5. So answer is 637.5 meters. Right. So how about question number 15? 15 kara. Question number 15. Others? No. Yes. Answer again on that. 14 है क्या? 14 में आपका प्रश्न क्या है? Question number 14. Okay. वाला मुझे देखिए. Question number 14 वाला. वाला 3 वाले. Question number 14. A particle starts moving in a straight line from a point capital A with a velocity 2 meters per second and a constant acceleration of 3 over 2. Actually, it's a deceleration, minus 3 over 2 meters per square second. It reaches point B with velocity of 6 meters per second. Find the displacement from A to B and time taken to travel from A to B. Right. So initial velocity at A is 2 meters per second. Final acceleration is minus 3 over 2 meters per square second. Final velocity is 6. Right. Find the displacement method. Displacement and time. Need to find displacement and time. Right. First we find the displacement. So we know initial velocity, acceleration, and final velocity. So you can use an equation with time independent. V squared equals u squared plus 2a. V is 6 squared. U is 2 plus 2. Acceleration is minus 3 over 2. Displacement is s. 6 squared is 36. 2 squared is 4. Minus 3s. So how it can be minus negative in the value? They got some question either. 12 question number 14 near the way. Constant acceleration make a negative network of the answer again. Answer the 48 meters, 48 meters. In an area. Another issue is displacement is negative. Negative value whether we have 3 years, 4 minus 36 years. Negative displacement become 10. Right. Whether way, since the since the final velocity has increased up to 6, so it can't be a deceleration. Final velocity initially so it can't, acceleration can't be negative. Neither. So make a negative in the back. Negative in the back. Right? So we have the common negative acceleration is 3 over 2 kilogram. So take this 4 to the other side. 3 years. So displacement is 32 over 3. 10.67 meters. Come on, right? Don't mind the given answer. So acceleration can't be negative there. Acceleration negative in the back. Velocity value in the back. Right then. Find the displacement from A to B and time taken to travel from A to B. Right, so you can get the time using this equation. Final velocity is V, initial velocity is final velocity is 6, initial velocity is 2, acceleration 3 over 2 time. 6 minus 2 equals 3 over 2 times T equals 8 over 3. 2.67. Maybe values of all of the common method practice well said. Take a question again. Stop with the that is obvious. I got a question. Maybe on the right. So how about question number 15? 15 no. 15 another question number 15. Right. Read the question number 15. A driver has a reaction time of 0.5 seconds and a maximum deceleration of 5 meters per square second for his vehicle. What is the minimum stopping distance required to bring the vehicle to rest from the speed of 10 meters per second? Right. A driver has a reaction time. So, what that means? So, what is the importance of reaction time to this question? How this reaction time involved in this question? Like, so how this reaction time affect to this question? Reaction time, a driver A driver has a reaction time of 0.5 seconds and a maximum deceleration of 5 meters per square second for his vehicle. What is the minimum stopping distance? Right. A driver sees an accident and he suddenly applies brakes, right? And try to stop the vehicle to prevent that accident, right? The question asks what is the minimum distance? And the question asks what is the minimum stopping distance required to bring the vehicle rest? So initially it is moving with 10 meters per second speed, and finally it has to come to rest. Right? So when the time equals 0, suppose the vehicle is at here, he sees that incident, right? At time equals 0, he sees that incident, and he thinks to apply the brake, right? So what? හිතපුවම බ්‍රේක් එක වදිනවද? එහෙම වෙන්නේ නැහැ. මයින්ඩ් එක වැඩ කරන්නේ නැහැ නේ. මේ මැසේජ් එක යන්න වෙනවා නේද? මැසේජ් එක අපේ brain එක through ගිහිල්ලා ඒක react වෙන්න time නැහැ. Right? So that is the reaction time. Right? So during the reaction time, so in between the reaction time, which is t equals 0 to t equals 0.5 seconds, so what is the velocity that vehicle is traveling? It maintains that constant speed throughout that reaction time period. The speed brakes applying there. Right. So during this 0.5 second, the vehicle maintains uniform velocity. Up to here, it keeps that 10 meters per second speed remain constant. Thereafter, after 0.5 seconds, now brake applies. Then vehicle decelerates. Deceleration is 5 meters per square second. Right? So now question asks, what is the minimum distance that vehicle has to before it stops? Right? So this is the minimum distance. Right? Finding this value of s has two legs. Right? So you need to find the distance where this vehicle travel with uniform velocity. This one S1, and also you need to add to it the displacement it has done with the deceleration. Deceleration එකත් එක්ක අපු displacement එක එකතු කරන්න ඕනේ. Right? First, find the distance that vehicle has traveled within the reaction time. Distance traveled during the reaction time, which is S1. So how do you find the distance? So what is the type of motion? It is constant uniform motion, right? So you can only use S equals ut. So u is 10, time is 0.5. So it has traveled 5 meters before applying the brakes. So then we need to add distance traveled after the brakes applied. So it is S2. So how do you find the S2 value? We know the deceleration, initial velocity, final velocity. Need to find the distance. This is initial velocity, this is final velocity. So you can use you can use this equation. V squared equals u squared plus 2as. Final velocity is 0. Initial velocity is 10. Deceleration is 5 S2. So value of S2 is 100 divided by 10 meters. So S2 is 10 meters. The question asks, what is the minimum stopping distance? So minimum stopping distance is equal to the sum of S1 and S2 distances. 5 plus 10, which is 15 meters. Right. So that's how you get the answer for the first part. Right. You can also write. Program is one and the use. Second part of it, what is the distance the vehicle would travel before stopping if its speed was 20 meters per second? Right. So the second part is, what is the distance the vehicle could travel before stopping if it is speed was 20? And now only change is speed now is 20, right? Repeat the same procedure, right? So only thing you need to change is take the speed as 20. So 20 into 0.5, 10 meters. Right? Here also the initial speed is 20. Deceleration is as same because same vehicle. Right? So Therefore, deceleration or force, the resistive force generated by the brakes, similar, right? It is same at the both the situations. So therefore, the deceleration is same. So this becomes 400 over 10, and it is 410. 40 meters. Right. The sum of the two displacements, 10 and 40, which is 50 meters. Okay, come on there, only change is the velocity, initial velocity is increased, it has increased. Right. Okay, now look at the question number 19. 19 में करा one thing, no? Question number 19. Question number 19, yes. 70. We need to do 70. Oh. Right. Okay, 70. Right. 17 tell okay. With the question. A particle moving with uniform acceleration along a straight line takes 3 and 5 seconds respectively to travel 2 consecutive kilometers. Find the acceleration of the particle. Right, question number 17. A particle, and these are the keywords, moving with uniform acceleration. Right, a particle is moving with uniform acceleration along the straight line takes 3 and 5 seconds respectively to travel 2 consecutive kilometers. Right. So suppose this is the first kilometer, which is 1000 meters, and it has taken 3 seconds to complete that distance, and to complete the second part, it has taken more time. So T is 5 seconds. The question asks, find the acceleration of the particle. Right. So let us take the acceleration as simple A. Acceleration as simple A. So how we think? Right. In this question, the known variables are limited. Right. Done the acceleration displacement time. Right. So let us take the initial velocity. The velocity when the observer sees this object is simple u. Right. So let's take the velocity at this moment as simple u, which is the initial velocity. Right. So now we know the distance or displacement 1000 meters and time. I'm going to take 2 equations which gives a relation with u and a. I'm going to take 2 equations in terms of simple u and a. Right? So, we have to construct for this period from A to B. So, what is the suitable kinematic equation in order to get an expression in terms of simple u and a? We know displacement, we know the time, right? So what is the kinematic equation we must use here to get an expression in terms of u and a? S equals ut plus half at square is applicable here. Displacement is 1000. Initial velocity simple u. Time is, we consider the motion from A to B, so which is 3 seconds, 3 seconds, and acceleration is simple A, time is 3 seconds. So 1000 equals 3U, 3 square is 9, 9 over 2, 8. By multiply all the terms from 2, so 2 into 1000, 2000, 2 into 3, 6, 6U, 9, 8 first expression. Then again, if we use same equation from considering the motion from B to C, you need to use another unknown variable because initial velocity here is unknown. So therefore, I consider motion from A to C because because acceleration is uniform. Since the acceleration is constant, so you can use a single kinematic equation to describe the motion from A to C. So I'm using S equals ut plus half at squared equation to this motion. Like what is the displacement? It has done from A to C, 2000. Initial velocity is u, time is 3 seconds plus 5 seconds, time is 8 seconds. Half, acceleration is A, time is 8. So 2000 equals 8u plus 8 square is 64, 64 divided by 2, 32. Right, so you can divide all the terms from 8 tonic better. 2000 divided by 8 is 250. U plus 4 times A, second equation. Now you have two equation. Solve this simultaneously. Simultaneously solve the graph. Find the acceleration. Right? Then you can simultaneously solve the graph. Okay, learning is done. Question number 2. Displacement line. Right? So now, so how we solve this? So we can find the value of simple A straight away. So doing this, so you can okay, multiply the equation 2 from 6 and subtract equation 1 from it. So 250 into 6 subtract equation 1, the value is 2000, right? So this u becomes 6u plus 6 times 4 is 24a minus 6u plus 4a. 250 into 6 is 1500 minus 2000 is negative 500. 6u plus 24a minus 6u minus 4a. So a is minus 500 over that. What is the up? Here it is 9a. This is 9. 9a. 15. Right. The common factor is 5. 100 divided by 3 minus 33.33 meters per square second. So answer is correct. Correct. Right. Next one. Question number 19. Question number 19. Right, read the question. A car starts from rest with an acceleration of 2 meters per square seconds, and at the moment it begins to move, a bus passes that point with a uniform velocity of 10 meters per second. What will be the velocity of the car when it overtakes the bus? How long will it take for that? Right. So I choose this question because there's a thing to mention here, right? So this is bit different from the questions we have solved before. In here, there is a motion. There are two motions. One is the motion of a bus. The other one, the motion of a car. Right. So both these vehicles starts their motion at the same time. Right. So that is important. Hey, again, a car starts from rest with an acceleration 2 meters per square second. So acceleration is 2 ms minus 2, and also its velocity at the moment it starts motion is 0. Start as rest, right? Then at the moment begins to move, bus passes the point. They are Okay, we have started with the bus passes that point with uniform velocity. Okay. Right. So question asks, what will be the velocity of the car when it overtakes the bus? So initially, bus is in front of the car. The bus is heading, right? But the speed of the bus is a constant one. Although the initial velocity is zero of the car, it has acceleration. So it accelerates. Like at a point, like at somewhere in the road or path, the car overtakes the bus. Right? The car overtakes the bus. The velocity of the bus is same, uniform. It is constant. But the velocity, final velocity of the car at the moment it overtakes the bus is need to find. But by looking at this diagram, what can you say about when the car overtakes the bus, the displacements done by bus and car must be what? Hello? Displacement done by the car and bus must be equal because they have started their motion at the same point or same position, right? When the two bodies starts their motion at the same location or same point, and after a time they will meet again, or someone overtakes the other one again. Remember, the displacement done by both the bodies must be equal. Displacement must be equal. And also, since the two motions are equal simultaneously, they start simultaneously. So time taken by both these vehicles when car overtakes the bus must be same. Time and displacement they come same thing. And they have started the motion at the same time. When car overtakes the bus after a while, right? Till that time, the displacement done by both the car and bus must be same. Also, time taken by the car to overtake the bus is the same, must be the same time that bus has traveled. Right. So now you need to somehow you need to construct two equations where the displacement and time involved. Right. First take the bus. First take the motion of the bus. So you can use S equals UT equation for the motion of the bus. Displacement is simple D. Initial velocity is 10. Time taken by the bus is T. D equals 10 times T. Equation 1. Then use S equals UT plus half AT squared for the motion of the car. Displacement done by the car is D. Initial velocity is 0. Half acceleration is 2. Time is T squared. So D equals T squared. Now you have two expressions in terms of D and T. Right? So what you need to do now? Equal both these equations. D or 10 times T equal T squared. So since T is not 0, you can divide both sides from T. So final answer is T is 10 seconds. T is 10 seconds. Alright, the question asks what will be the velocity of the car when it overtakes the bus. So use V equals U plus AT to car. Final velocity V, initial velocity is 0, acceleration is 2, time is 10 seconds. Final velocity of the car is 20. And the part 2, how far will the car have to travel by the right? So the distance that car has traveled is given by d equals t square. T is 10, 10 square is 100. So distance is 100 meters. Like that. Because PJ Kasi to is Alta. Alina. PJ Kasi. Ah. Yes, sir. Very good. Okay. 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 Right. Remember when means again. Write down this. Must be equal. Like write down that if the two bodies start their motion at the same point, and meets again during the motion, then the total displacement done by the two bodies must be equal. this will be important for some MCQ questions in future. Right? So therefore, එකම තැනින් පටන් අරගෙන කෙනෙක් දෙන්නෙක් ආයි කොහෙද තැනක හම්බ වෙනවා නම් displacement equal වෙන්න ඕනේ. Right? And also we go further if they both these bodies start their motion at the same time, at the same moment, the time is also equal. So now we are in mechanics, not the measuring instrument. Spirometer තියෙනවා අපිට අපි ඒක start කරේ නැහැ, right? But now we are slowly. Now we are going to the depth of the subject, right? So මේක හරියට practice කරන්න. Okay. So with that question, I would like to jump to the MCQ questions. Question එකක් තියෙන මේකත් එක්ක simultaneously යන question එකක් තියෙන ඒකම එක choose කරන්නේ. Question number 6. MCQ question number 6. Right? Did I ask you MCQs? No. Sorry, right? Right. Another question. Okay. So look at the question number 6. Question number 6. 10 seconds. 10 seconds आराम से ऊपर ना. 10 seconds तो परिबाल वहाँ पे ना. A motor car and bus are stopped at the red light on a road. The motor car stopped 100 meters behind the bus. So motor car එකක් තියෙනවා. මේකේ motor car එකක් තියෙනවා bus එකක් තියෙනවා. Stop at the red light on a road. The motor car stopped 100 meters behind. Motor car එක තියෙන්නේ 100 meters behind you. This is motor car. Right? So this is the bus. So now, and initially it is 100 meters behind from the bus when t equals 0. When the traffic light turns green, the motor car starts with the acceleration of 6. Right. When the traffic light turn on to green, start the motion with an acceleration of 6. And also bus accelerates with an acceleration of 4. What is the time taken for motor car to overtake the bus? During this motion, at somewhere this motor car overtakes the bus. Mommy, it won't be in the bus. Can symbolize it, right? Again, displacement as a motor car and the bus is at the same position, right? After, suppose it's time t naught. Right? After time t naught, the motor car and bus at the same point, right? So suppose the distance that bus had traveled during this time period is s. Right? If the distance traveled by the bus during the time interval t naught is s, so what is the total displacement of motor car? What should be the total displacement of the motor car during this time interval? Initially, motor car is 100 meters behind the bus. Right? They start their motion simultaneously at the same time. Right? Then bus has elapsed some distance, and after time equals t naught, they are here. Right? So I'm asking you, if the displacement done by the bus is simple S, what is the displacement done by the motor car? 100 plus S, right? So for motor car, we apply S equals U plus half AT square. Distance traveled by motor car is S plus 100. Initial velocity is 0. Acceleration 6. Time is T naught square. So S plus 100 equals 3 T naught square. Equation 1. For the bus, use similar equation, half AT square. So distance is S, U is 0, half, acceleration is 4, time is T naught. So S equals 2 T naught square. Right. Now use equation 1 and 2, find the time T naught. From equation 1 and 2, right, instead of S, you can use T plus 2 T naught square. 2 T naught square plus 100 is 3 T naught square. 100 equals 3 T naught square minus 2 T naught square. So 100 equals T naught square. T naught is 10. 10 seconds. T naught is 10. Finished? Right? Huh? Evaluate that. So you need to write how the what is the method to use to find the acceleration? Method that we have. Take it on. Yeah. RG. Acceleration at time. So right the question discuss complete the sentences by using graph. Complete sentences. So acceleration at F may be positive, negative, 0. I will mention that. No need to find the value. Right. Okay, question number 21. Essay question. Now देखा याद है? ये बस देखा. बस MCQ questions. Right, 21. Answer. What about the others? Question number 21. No. Okay. Let's do. Let's do the question number 21. Figure maker. The meaning I can repeat the name very ठीक है वो तो मालूम नहीं तो इधर ही कहा जाता है right. Question number 21. A train starting from rest accelerates uniformly at 11/30 meters per square second to plus 60 seconds. Right. So there's a train starts at rest. So starts at rest and accelerate uniformly, the acceleration is 30 over 11. Oh, sorry, 11 over 30. Right? For time equals 60 seconds. Then it attains a velocity. After that, then moves with constant velocity in the next part. So the second leg, it is moving with constant speed. Then decelerates and comes to rest. Finally decelerates and comes to rest. Total time taken for this journey is 600. Find the maximum velocity of the train and the total displacement. The deceleration is 11 over 10. Deceleration is 11 over 10. Right. So how we approach this? First, you need to focus on what the question asks. It asks find the maximum velocity. Then you need to think where the velocity is maximum. Where the velocity get maximum? What the velocity maximum when? At what point? And initially? No. Right? And this period? Does the velocity get maximum? No. What when? Initially, the body starts with rest, train starts with rest, right? Then accelerate and obtain the maximum velocity at here. Then maintain that velocity for a period. Then decelerate. Right? So the maximum velocity is at this point. Right? So when it done the acceleration period, right? When the method. So how we get the maximum velocity? They have given us the acceleration, initial velocity, time you know. So suppose this point is A, this is B, C, and D. So you can use the kinematic equation for this period. So V equals U plus AP. Since we need to find the final velocity, initial velocity is 0, acceleration is 11 over 30, time is 60, 11 times 2, 22. The maximum velocity is 22. Maximum velocity is 22. Maximum velocity is 22, right? Then, find the total displacement. Right. So total displacement consists with three parts. So displacement during the acceleration period is S1. Displacement during the displacement done by the uniform motion is S2. Displacement when the body will decelerate is S3. So total displacement is sum of these three displacements. Right. So since we know all the kinematics quantities other than the displacement for the period of acceleration, so you can use this, you can find this S1 value. Use S equals ut plus half AP squared to motion of the body from A to B. S1 initial velocity is 0. Acceleration is 11 over 3. Time is 60 squared. 30. 60 over 30 is the So S1 is 11 times 60, which is 660 meters. 660. Right? Then thereafter the question. So how do you find the other displacements? Now you have found the S1 value. So how you find the S2 and S3 value? Can you find S2 value directly here? Because although we know the uniform velocity which is 22, right? So you can use S equals UD to this period, but we do not know what is the value of time, t here. Isn't it? Time where the body travel with uniform velocity, we do not know that, right? So in order to find the time related to this period, you can easily find the time that body decelerates, right? So from C to D motion, the motion of the body from C to D, so you can find out the deceleration time by using V equals U plus AT. Final velocity is 0. Initial velocity is the velocity at this point, which is 22. Deceleration is 11 over 10. Time is 11 over 10. P is 22. 2 times 10. Deceleration time is 20 seconds. Deceleration time is 20 seconds. Since the total time is 160, right? So total time includes time that accelerates, which is 60, time which the body has traveled with uniform velocity, du, and finally time that body decelerates. The sum of these three times is 160. So the time that body travel with uniform velocity is 80 seconds. 80 seconds. Is that sorry 600? This is 600. This is 600. So time is 520. Now you can find S2. Use S equals UT. S is S2. Uniform velocity is 22. 520 is the time. So answer will be 11,440 meters. Is it? Okay, then 11,440. Then finally, from the motion from C to D, find the S3 value. S equals U plus over 2 times T. Initial velocity when the deceleration starts is 22. Final velocity is 0. Time is 20. 440 divided by 2, which is 220 meters. This is the value of S3. So therefore, total displacement of the body is S1 plus S2 plus S3, 660 plus 11,440 plus 220, 12,320 meters. These are the answers. Final question. Question number 2. So what the answer? Question number 22. Done. Good. Right. deceleration without deceleration the acceleration. Find the distance traveled with uniform velocity. The acceleration, if it is 0.5, and the deceleration. Initially deceleration is acceleration 5 and that's what right. You are going to right. An object starting from rest first moves with uniform acceleration, then with a uniform velocity of 10 meters per second, and finally moves with uniform deceleration and comes to rest. The total time taken for this journey was 160, and the displacement was 1.2 kilometers. Find the distance traveled with uniform velocity. Right. I'm going to make my list now. Right. Question number 22. An object starting from rest, u is 0 at point A, moves with uniform acceleration, then with a uniform velocity of 10. And finally, decelerates. Right. Suppose this distance is S1, distance here is S2, distance here is S3. So total distance is given by sum of these three, which is 1,200 kilometers. Sorry, meters. Right. So let's take the time that accelerated T1, time that body traveled with uniform velocity is T2, and time that decelerated is T3. So T1 plus T2 plus T3 gives the total time, which is 160. Right? So here I am going to subject T1 plus T3. So it is 160 minus T2. Make this equation. Right. Now right. Since we doesn't know the initial velocity, but here we know the final velocity after time t1. So this is what we need to do. Right? This is. So I'm going to take three equations for S1, S2, and S3. Right? So my plan is to get three expressions for S1, S2, and S3 in terms of T1, T2, and T3. Then I'm going to add those three equations. Right? So adding those three equations gives the S1 plus S2 plus S3, which is equal to 1,200. Right? Thereafter we'll see what happens. Right? Only copy expressions from down. Right? Tell me, so what is the how we get an expression for S1 in terms of T1 without without knowing the acceleration. So since we doesn't know the acceleration, right, we need to focus on expressions which the acceleration is not there, right? The equation we use must be contained initial velocity, final velocity, time, and displacement. Right? So what is the equation you can use here? Equation without acceleration. There's only one equation there without acceleration. Which one? S equals u plus v over 2 times t. Right. So from A to B, use S equals u plus v over 2 times t. Displacement is S1. U is 0. Final velocity is 10 over 2. Time is t1. 5t1. First equation. Right. Then from the to the motion from B to C. This is a motion with uniform velocity. So only equation you can use S equals ut. S2 equals u is 10 t2. Second one. Then from C to D, third equation, again use S equals u plus v over 2 times t. X3, initial velocity is 10, final velocity is 0, time is t3. 10 divided by 2 is 5, S3 is 5 times t3. So now I have taken three equations with T1, T2 and T3, and the other side S1, S2 and S3 is there. So now I am going to add those three. Right? Adding those three, in the left hand side, we have a S1 plus S2 plus S3. And the other side, 5T1 plus 10T2 plus 5T3. Right. So value of this term is 1200. Right. So 5 is a common factor of these two terms. T1 plus T3 in T2. That's why I subjected that T1 plus T3 because it is 160 minus T2. So T1 plus T3 is 160 minus T2. Right. Expand the brackets. 5 into 160, 800. 5 into minus T2, minus 5 T2. Take this 800 to the other side. 1200 minus 800 is 400. Minus 5 plus 10 plus 5. T2 is 400 divided by 5. 80. 80 seconds. Right? But the question asks, find the distance traveled with uniform velocity, which is S2. S2 is 10, T2. T2 is 80. So answer is 800. So that's how you need to do. Other answer is graph in the pen. Only you need to use kinematic equations. You are not allowed to use graphs because this is still behind the kinematic equation. Right? Make R with the kinematic. Common exam specify but I gave this under the kinematic equation, so you can only use kinematic equations. Yes, but here it is not relevant. The question is use the kinematic equation and solve the kinematic equation using the VT graph you can solve this problem either way, right? But in terms of kinematic equations, only graphically, other nearby. Well, I want a graph way, other over. Graphs there actually. Other over other maybe equations. Right? Copy this. Copy this is actually this is a good question. Right? Done. कहाँ से कहा पेन है schools पढ़ाना नहीं है लगता next week करो and then like Itu yuk no tahu apa dekat ada right next part if the acceleration is 0.5 find the deceleration now it says if the acceleration is 0.5 now they have given the acceleration is 0.5 find the deceleration since the acceleration is known find the time that body accelerated finding the time the body accelerated, right? So you can use v equals u plus at. Final velocity of the body is 10, initial velocity is 0, acceleration is 0.5, time is t. So t is 10 divided by 0.5, which is 20 seconds. 20 seconds, right? So now you know the period, time period where the body accelerated and also the time that it has traveled with uniform velocity. Since the total time is 160, T1 is 20, T2 is 80, Find the value of T3. 160 minus 100. 60 seconds. 60 seconds. 60 seconds. Right? 60 seconds is the time that body decelerates. Then find the deceleration. Find the deceleration. Right? Use V equals U plus CT to motion of the body from C to D. Final velocity is 0, initial velocity is 10, deceleration is unknown, time is 60. 60 times A is minus 10, A is minus 10 over 60, which is 1 over 6, negative 1. Right? MCQ the answers we since some of you have not tried the answer MCQ questions, answers to get first question answer to be 5. Sorry, 2. Answer is 2. Right? We'll write an item. Request करते हैं माँ अदर ना करन दिया एक अदर ना मांगी अदर है एक request करते हैं मांगी अदर ना कोई विदावत ये नहीं सा right I think second question we did here no 28 is the answer third one 3 is the answer question number 3 answer is 5 10 meters question number 4 what is the answer? So 60 meters. Question number 5, answer is 1. 6, we did it earlier. Question number 7, what is the answer? 40. 40. Question number 8, answer is 5. 5. Question number 9. So deceleration like 1.5. 10 seconds. What is the acceleration of the body? And the acceleration is it 6? No. But should be 24. Fourth one. So are there any difficult questions? No, other than make a question because I need to tell you something. Right, question number 4 and 5. 4 and 5. Now what is it? One more is it? Question number 1 other. Yeah? No, right, මම ඉස්සර බලන question number මේ over කියන පොඩි දෙයක් කියලා දෙන්න එක. right? ඒක පොඩි ඒකේ චුටි දෙයක් හිතන දෙයක් කියනවා අපිට ඉස්සරහට වැදගත් වෙනවා කිව්වොත් හිතෙනවා. right, මේ බලන්න. Well, the question number 4 says an object starting from rest accelerates uniformly and covers a distance of 20 meters in the first second. Question number 4. It says an object starting with rest and accelerates right? During its first second, it has traveled 20 meters, right? So, instead of 20 meters, I will take a distance of simple s. It has traveled in the first second. Then the question asks, what is the distance covered in its second? Second. Right. So suppose the distance is s dash. Question asks about this s dash. They have given this one, it is 20. But now I'm going to take a general expression for this kind of question. Since the acceleration is uniform and the time is 1 second, right? So you can use s equals ut plus half at squared expression to here. Distance is s, initial velocity is 0, half, acceleration is a, time is 1 second. I first second, 1 second. So s equals a over 2. So acceleration is now 2 times s. This is the acceleration of the body. Right? If they have given, actually for this case, acceleration is 40, 2 times 20, it is 40. Again, right? If a question gives you the distance that object has traveled within its first second, right? And it has started the motion at rest. Like acceleration is 2 times of the distance it has traveled during its first second. Right? Here it is 20, so acceleration is 40 meters per second. මෙයා rest එක start කරලා නේද? එයාගේ displacement එක දෙනවා first second එකේ යන acceleration එක unknown ගන්න. එයාගේ acceleration එක වෙන්නේ මේකේ distance එක වගේ 2 times meters per second. Right? That is one thing. Then, so how do you find the distance it has traveled during second, right? So suppose here the velocity attained after 1 second is v. So we use v equals to plus at. U is 0, acceleration is 2s, time is s. So velocity is 2 times of displacement r. Velocity is also equal to 2 times of displacement. Right? For this question, velocity at here is 40 meters per second. 2 times of displacement. 2 into 20 meters per second. Right? Then, so let's find the distance it has traveled during second. Again, use s equals u t plus half a t square. So now the distance is s dash. Initial velocity here v, which is 2s. Time is 1 second. From 1 second to 2 seconds. Time is 1 second. Half. Acceleration, which is constant. 2s. Here 2s. Time is 1 second. Square. 2s plus 2s divided by 2, it is s. So 3 times s. Right? So the distance it has traveled during its second is 3 times of the distance it has covered during its first second. So here 3 s is 20, so s dash is 60 meters. මතක තියාගන්න ගමුලුවේ තියාගන්න යුනිෆෝම් ඇක්සලරේෂන් යන බොඩි එක යාගේ ෆස්ට් සෙකන්ඩ් එකේදී යා ස්ටාර්ට් කරන ඉනිෂියල් රෙස්ට් එකේ නා ෆස්ට් සෙකන්ඩ් එකේ ඩිස්ටන්ස් වගේ 3 ටයිම්ස් යනවා යාගේ සෙකන්ඩ් හරි ෆස්ට් සෙකන්ඩ් එකේදී ආයන්නේ 10 meters නා සෙකන්ඩ් එකේදී යනවා එක 30 meters හරි යුනිෆෝම් ඇක්සලරේෂන් ස්ටාර්ට් කරන රෙස්ට් එක First second එකේදී ආවෙනවා නම් 50 meter, second එකේදී ආව කරනවා 150 meters. හරි ඔය MCQs වලට ඕනේ දැන් ඔය හදා දින්න ඕනේ නේද ටක් ගාලා ඔළුවේ තියනවා දැන් ෆස්ට් සෙකන්ඩ් එකේදී මෙච්චරක් කරනවා නම් සෙකන්ඩ් එකේදී අපි 3 times යනවා හරි දැන් තමයි මේ MCQ එක නාවා ඒකෙන් තව එන්න පුළුවන් මොනවද ඒකෙන් තීර එකක් කියලා දෙයක් ගන්න හරි ඒක question එක discuss අර acceleration එක දෙවොත් final value එක right fifth question a motor car starting from rest moves with a constant acceleration fifth one a motor car starting from rest moves with a constant acceleration starting from rest moving with constant acceleration suppose it is a if it is velocity after n seconds right velocity after simple n seconds velocity capital V is after simple n seconds then the question asks its displacement in the last 2 seconds. Displacement in the last 2 seconds, which is from the time from n minus 2 to n. The question asks displacement here. Where displacement right. So, in order to find the displacement here, of course, we know the time interval is from this point to here is 2 seconds. So first of all, we need to find out, or we need to find what is the acceleration. And since the acceleration is uniform throughout the motion, let's find the acceleration. Finding the acceleration. So use v equals u plus at. Final velocity after simple n time period is v. Initial velocity is 0. Acceleration a. Time is n. Acceleration is v over n. Right. So my plan is to use s equals ut plus half at square equation to this period. So acceleration we have found v over n, right? Time we know 2 seconds. Then we need to find the initial velocity here. So suppose it is u dash, right? That means u dash is the velocity after n minus 2 seconds, right? From A to B, here we consider motion from B to C. Now, Considering the motion from A to B, use V equals U plus AT. Final velocity is U dash. Initial velocity is 0. Acceleration is V over N. Time at here is N minus 2. So U dash is V N minus 2 over N. Now, again, to the section from B to C, apply ST equals UT plus half AT square. S initial velocity is U dash. Here's the value of U dash. N minus 2 times V divided by N. Time. What is the time period? From N minus 2 to N. Time interval is 2 seconds. Last 2 seconds. So T is 2. Time interval එක දාන්නේ මෙතන මෙෂර් time එක නෙවෙයි. මේ interval එක. කොච්චර time period එකක් ගියාම මේ motion එක කරලා we to see 2 seconds. So it is 2 plus half. Acceleration is V over N. Time is 2. So you have 2 times V divided by N. N minus 2. Right. So 2 will cancel. Again 2V over N. There's a common term in this expression which is V over N. Taking it out. N minus 2. When you took 2V over N out of the parenthesis, so remain is 1. 2 over V times N. Minus 2, N minus 2 plus 1 is N minus 1. So this is the final answer. 2V N minus 1 over N. Right. Say they don't pay the discuss them. Fine. Motion graph start. Like video.